All right, so today we are going to be dealing with object-oriented programming. And we are primarily going to be dealing with Python because Python is an object-oriented programming language. We can think of object-oriented programming as being the most natural and intuitive approach to programming because it is really objectified thinking. Think about what it's like when people are born. As infants, we learn about the world around us through direct interaction. We associate elements of the world as objects or nouns. As infants, we're not yet concerned with why or how things are. We don't establish a sense of the subjective self until early childhood. And that's really the core analogy to think of here when comparing object-oriented programming to other programming models. Object-oriented programming is objective. It really defines what things are. It deals with nouns, whereas declarative programming is more subjective. It defines what things should be. Functional programming deals with verbs or what things should be able to do, whereas procedural programming describes the actions that things take, cause and effect in a sense. And logical programming will deal with relationships or how things should specifically interact. So in this sense, object-oriented programming is foundational and fundamental. You really can't learn more advanced programming methodologies without first understanding object-oriented programming. So it's the most accessible, it's always going to be in demand, and this is why we are teaching this first. Objects are the fundamental and primary focus of object-oriented programming, as the name implies. But with that alone, we wouldn't get too far. Yes, declarative programming focuses on subjective declarations, but that doesn't mean it has exclusive ownership to this. Declarations are important in object-oriented programming as well. Let's go back to the baby scenario. We first learn to interact with the world around us by identifying and associating with nouns or objects. But what if we never evolve beyond that? What if we never learn to distinguish subjectivity between objects? What if we never learned the difference between you, I, him, her, them, us, etc.? We wouldn't be able to communicate the way we do without being able to distinguish subjectivity between objects. So declarations are still crucial, but in object-oriented programming, objects are king. We define everything through the assignment of variables. So everything is an object first and foremost. Even class, in a sense, is an object. We have to create a variable to contain the declarations within a class before we could inscribe anything to that class. And when we inscribe things to class being a type, what we're doing is we are instantiating an object, a class instance specifically. So we have classes, which are types of objects, and objects, which are basically everything else. Objects don't necessarily have to be assigned to a class, but everything within Python, for example, will have a built-in type. So whether you assign something to a class or not, it's going to be assigned to a variable, and it's going to have a type. It's going to be a Boolean, it's going to be a string, an integer, whatever. It can't exist without a type. Because class objects are known as instances, the process by which they are created is known as class instantiation. Once a class has been defined, it can be called, just like a function can be called, to instantiate a new instance. And let's see. The syntax for doing this is basically called, I forget what it's called. It's like parenthesis notation, I think, or something like that. But it's what you see at the bottom of the screen here. We have a variable on the left side, instance name, and that is what we are assigning class name with parentheses to. You can define a class by calling the reserved keyword class, followed by the name you want to give your class. And within this class scope, you can define attributes and functions just like you would outside of the class, the global scope. All objects instantiated from the class will contain their own unique values for the attributes and methods defined in the class scope. So in this example up here, we have a class called class name. Its default attributes would be things like the class attribute string, the class attribute integer. When you instantiate an object of this class, which we're going to call instance name, it will have its own container for the class attribute string and the class attribute integer, which it will inherit from the class that it's taking these parameters from. Any questions so far? Cool. Reserved keywords in Python, like class, are keywords that cannot be used for anything else. These definitions cannot be changed and they cannot be overridden, and objects are not allowed to use any reserved keywords of its name. So if you run into any errors when you're trying to define or name your parameters or variables, you should check sometimes to make sure that you're not using an otherwise reserved keyword. So class instantiation in Python basically looks like this. We have a book with a title and an author. These are default values that can be thought of as placeholders. So here in the second block, we are instantiating a new book instance. And if we were to print the title or the author that it had inherited from the class it's being instantiated from, we would see the placeholder values. Now we can assign new values to those parameters like we see in this third block here. And if we were to run print statements after doing so, we would see the updated values. So generally, when an object is instantiated from a class, the attributes it contains will be null or empty values or predefined. This means that you will have to execute additional statements in order to assign the values you want your instance object to have for each attribute. The more attributes defined in your class, the more additional statements you'll have to create. And here in this example, we have a different way of instantiating. We have the class defined up at the very top where we are using the built-in init method to assign values to title and author. So this is basically saying when a book is instantiated, it will have a title that will equal the title being passed in and an author equal to the author being passed in. So whenever you see anything inside parentheses, these are parameters that could be passed into a function. And again, remember, when we are instantiating class instances, we're essentially executing these like function calls. We're calling a built-in Python method to instantiate the class. So in this bottom example, we are calling the book class, and we are passing in Catcher in the Rye and J.D. Salinger as values to these parameters, title and author. And so once we print the book title, we have the Catcher in the Rye title. This is basically a faster way of instantiating a class, because if we were to say use classes or instantiate a few classes of a class that had like 30 parameters, you really wouldn't want to type out each parameter line by line by line by line. You would want to utilize some kind of built-in method like init to make it scalable, easy to assign the proper values as these are being instantiated. Any questions? Cool. That is, oh, please tell me I didn't forget to record. Am I recording?
Yeah.
Okay, cool. Let's see. I'm gonna switch gears here. I really don't think there's actually too much more. Everything in this slide deck is taken from the README for today. And I'm just gonna gloss over the README, see if there's anything that I didn't cover, and it really doesn't look like there was. So let's go ahead and step through the challenge real quick. It's this one. Okay. So everything we covered is going to be in this README. We are inside of software engineering, Python OOP intro 1, and at the end, maybe it goes into the init built-in init method a little more in depth, but basically everything you'll need to know about it will be referenced here. And today's challenge will be app users. Like usual, man, still can't fork these. For now, just copy this URL to clone this repo locally and work from there. You will be building an application by first creating a user class and creating parameters for that class. And wow, that's really about it. So while you are doing that, I will whip up another challenge and I will let you all go into breakout rooms. And when you finish with the challenge, just head back to the main room. Once everyone is back, they'll kind of be my signal for releasing the next challenge. Any questions? Cool. All right. Yeah, you're free to go ahead and break out into any of these breakout rooms.
Uh, we just define the class like the self-started as a name, email, driver license name. If nothing shows up, it'll be none. If you don't have it. So basically have name, like class has name, email class has email. And it's basically the same thing for so I just found like a structure and then I put in all the things like put in there. But this is the contents that's what they have. User 2, user 3, and then print it out. And that's the result we got.
Awesome. Great work. This is perfect. Very clean, yes, very clean and very neat. Great work. All right, let's have one more example. Chad, why don't you share you have?
You caught me working on the Armstrong numbers. All right, 1 second. Let me just get back up here. Close this out. Almost ready. All right, can you guys see my VS Code? I don't know if I hit the right screen or not.
Yep, I can see it.
Okay. All right. You guys just want to see it, right? That's all you're really looking to see it.
Yeah, just talk through it and maybe run in console.
So I wrote a cupcake subscriber user. And so in my init, I have the name, address, email, favorite frosting flavor and food allergies. And then all the variables here. And then I just went ahead and added a string variable so I could print it out, because I forgot that if you don't have this and you try to print it out like this here, it just prints out the object.
Right.
I think I saw this. I can do it without that, actually. So you'll see it's got Johnny, D, and Jane.
Mhm.
And then if I comment that, see that this is just the object here. I guess it just points at it. I've never been able to really truly explain this, but I guess it's just like where the object's location is in memory,
Mhm.
something like that. And then if you run it now, you'll actually get to see this little guy here.
Awesome. Awesome. Great work.
Is that correct, Julius? This here, is it the object's location, or Nicholas? Is that?
Yeah, in the working memory, pretty much.
Yeah, that's what I see there when I see like that. Okay, cool. Excellent. Thank you.
Yep. All right. So let's see. Yeah, I guess you have to bear with us at the start of this curriculum because a lot of this can feel very basic and slow. Let me run through this part 2 real quick, and I'll let you all move back into the challenges. Okay, this should be it. Cool. Let me know if my text is too small. I'll increase it a bit, and let's kick it off. So, just as we learned earlier, class could be thought of as templates for objects. And just as you all have demonstrated through app users 1, you can instantiate objects. You could use the special init method to define different parameters in the class. And when you instantiate your class instances, they will inherit all of those properties. So let's see, is there anything here that's really new? Here we're talking about just additional points to using the init method, naming your method whatever you like. Right, this is just going over what could go wrong if you weren't to include the parameters that you've defined inside of your class. So here we have class, it requires a color parameter. And when we try to instantiate without passing that in, we will be given an error. So again, just being mindful of how classes are built and adhering to the parameters that they are requiring will help you when you are troubleshooting, writing and troubleshooting code. What's next? We have modifying class and instant attribute through methods. Okay, so here's something that's a little new, still nothing too challenging, but just like how you can call the built-in init method, or define, I should say in this case, but you're really technically calling it because it's already built in. You can define additional methods, such as this update breed method for this dog class example. We are taking the breed and we are updating the breed. So in this example, we have a dog, we're giving it a name of Carl, and we're passing in a Cocker Spaniel. Initially, when you instantiate this dog C instance, and you were to print the name of this dog, it will return Cocker Spaniel. Now, if you were to call the update breed method and pass it, what is this, Kanan, I guess? I've never heard of that breed before. Then it will update the breed of that instance and that instance only. Well, we could see that dog D will continue to be a dachshund. Because breed is defined as an instant variable, modifying its value only affects the instance it is modified for. And because color is a class variable, its value is modified for all instances. So I guess in this example, when we update, it looks like this example needs to be fixed. I think what they were trying to do is update the value for the class and not the instance, because this doesn't make any sense. If we were to ignore this line and pretend that it says dog.color equals brindle, then we would see that the color for dog C and dog D would also update to brindle. And that's really about it. I think application users 2 is also fairly straightforward. You're really just adding a method, new feature to your app called posts, a method to your user that allows for creating new user posts. Let's see. And then of course there's the Armstrong numbers. An example is all single digit numbers, blah, blah, blah. Yeah, I'm sure a few of you have already started this. Again, if these are too easy, too quick, I'll see if I could whip up another challenge before the end of the day. Otherwise, if you have any questions, hit up either Nick or myself, and I will open up breakout rooms again. I think this time, yeah, I'll open up breakout rooms. And we will check in real quick before the end of the day at about 4:30. Sound good? Cool. All right, let me stop sharing. Did I forget to record again? No, there it is.
Recording.
Yeah, I'm not a big fan of Zoom. I can never get used to it. All right, let's cut this out.
All right, so it's a little variable heavy for what I would have liked, but fundamentally it takes numbers, makes a variable that's a string, and then it slices it up. It takes the first value in the stack and makes it the numpal because it's going to be to the power of that number.
Mhm.
I create an empty list, and then fundamentally, if it's 1 digit in length, it's going to be true just by the way the numbers work. So if length is 1, then return true, and if it is not, then it's going to go through for each number in the number string, and it's going to output into the final list as an integer each number to the power of numpal. And then check num is the number it checks against, and that's the sum of the final list. And then if check num is equal to the original numbers, it returns true. Otherwise, it returns false.
Cool. So a quick question before we run this demo. What is the num list again? Because I see that it's not actually being used.
It might be a legacy. I had to rework it a couple of times. I actually think that numList was what it was before I ended up with this for loop, because I realized, hey, I can make a string out of it. And I was like, why am I making a string just to take the string and make it integers? So I believe numList ended up being for number and num. And then this obviously outputs not a string, but integers.
Right. Awesome. Okay. All right. Let's see it in action.
Okay. So So obviously that's a lot on screen. Give me just a second. But the call at the bottom is a print statement for 371, which is an Armstrong number, and
Mhm.
then it returns true.
Okay, and let's try it with a non-Armstrong number.
55. I hope that's not an Armstrong number. I don't have it memorized. And then
Nice. Awesome. Have you tried like any extreme I guess edge cases? Like, do you know what would happen if we put in like a negative number or a non-integer, for example?
it probably would throw an error for
Okay.
integers because I don't have an allowance. And if we were gonna well, let's see what happens with -5. If my VM melts, I'm gonna use it as a tax write-off. Let's see here. Yeah, so I would need a if the number is less than 0, then because I'm pretty sure 0 would still be all right.
Mhm.
But yeah, just adding encapsulation with if the number is less than 0, just return false. Or yeah, I need to look at that. Yeah, so 0 is still good.
Okay, that's awesome. This works great. When it comes to edge cases, something to keep in mind is, let's say you're building out some kind of component functionality for an application that's going to be used by your customer service team, for example, or maybe even end users, customers for the actual business. If you anticipate, let's say user error ahead of time, and anticipate an example of like maybe somebody inputting a negative number or a non-integer, rather than just leaving it in a state that it will error out, you could anticipate that and build in with essentially a graceful failure, like something along the lines of returning a message saying you can't input that. That's not the proper input. I can't accept that input because it's going to cause a kind of failure.
Yep.
Just something to keep in mind when building functionality out and for testing as well.
Yeah, absolutely. Obviously, errors are the doorway to exploitation as well. So
Right on. Well said. All right, great work. Let's see. Does anyone else want to run through their Armstrong? If it's not finished, we could maybe troubleshoot it as a group as well.
Yeah, I need a little help. I'm so close.
Right on. All right, let's take a look.
All right. So I checked it for if it was just a regular number, like 371, and then if it was a list of numbers. And this one works. If it's just like 371, it will push the number into this list I have. And then I just set it up so it returns every Armstrong number. And the one for the list is stopping at the first number.
Okay.
And I just don't see why it's not continuing the loop.
Well, the first thing I'm seeing is we're iterating through number in numbers. We're not iterating through list.
So numbers would be a list.
Mhm.
Right. So it's grabbing the first number in the list.
And of numbers is what we're passing in. I see that. Okay.
And then I grab the first digit of that number by turning it into a string. So doing the nested for loop to get that first digit as a string, turning it back into an int to multiply it by the power. So it's doing this whole thing.
Let's add a console log somewhere within that for loop. And then let's iterate through the entire thing and see what's happening.
The first or second one loop.
We could start with the first one. We want to see where it stops iterating. I'm thinking it might have something to do with how the entire conditional is set up.
Two, three, four.
And you ran this to, it's still running all of those examples at the bottom, right? And not just the last one. We could comment out
Yeah.
27 and 28. So it looks like it is iterating through the entire thing, but it's only returning that final value
Yeah, but well, no, because this is,
or that first value.
oh yeah, that is all the numbers. Okay. Yeah, so we know the first loop is working then.
Mhm.
Did I get rid of the other? I don't know what is happening here. 1, 2, 3, 4, 5, 6. So it's doing those 3 each.
Mhm.
Oh, because the power.
Okay.
So that's where it's messing up.
So ultimately, it's returning Armstrong as a list with only one value at the end. And it seems to only be returning 2 each time.
Yeah, and what I can see though, see how it's doing the larger numbers 3 times because that's how many digits are each.
Mhm.
So it's not multiplying by the power, it's just printing it or looping through it multiple times.
Okay, let's go back to that loop. So we're going for the digit in the string of this number. So if it's a 3-digit number, it's going to go for each digit. It's printing the entire number. And then it is adding that specific digit.
Yeah, it's like reading through it, it's making sense. Let me see what digit actually brings up.
71371.
27137. Yeah, so that's going correctly.
So if the sum equals the number, then we want Armstrong to append that number, but it's not appending that number.
Just the first time.
So
What if I put something that's not? And it's just empty. So no matter what, it's stopping at that first number.
I wonder if it's because well, no. Stop me that.
It's a nested loop, but I'm not sure.
I comment this out. Oops.
I'll have to convert that to a regular if.
Wasn't sure if they were clashing somehow. I've been stuck at this point for like an hour, losing my mind.
So we know that it's not appending any of the additional. Let's look at line 17, 18, and 19 again, and let's talk through it a little more. So as we know it's iterating through every digit in a number, but we also know that it's not properly appending all the valid numbers. So we have a sum. Is the sum at any point being reset? Or is it continuing to increase in value, including the sum from the previous iterations of the loop?
Yeah. Maybe it's not resetting like I expected to. Oh, do I just have to
You could say,
sum equals 0 again or something?
right, I would say maybe between line 13 and 14. Or maybe even.
No, I was gonna say lower once
Yeah.
it's done the operation.
Mhm.
But it's gonna check.
It might have to be in between those
Oh.
two for loops, so maybe between 15 and 16.
I mean, why not append it and then clear it?
I guess I can add an else.
Right, it could also clear after.
So I could do sum equals 0, else sum equals 0.
Nice.
Oh, but it didn't get the last one.
Do we need that second else though? I think that's a little redundant. Or actually, no, you're right.
Yeah, because that's I keep going.
Right.
So it's going, the first one's not, and it's skipping that, and it's got all of these. It should skip this one. And it's just not getting the last one.
Let's do a console log to see what the sum is when it gets to that point.
Right here? Or the else?
Print, I mean. I think it would be fine there. I think that should still tell us enough.
No, I won't do that.
Okay, so it's reaching that second half of the conditional, maybe the else. So let's try putting a print in there too, between 22 and 23. $343.
What the?
And the math's getting a little wonky. So why is it? Could it
I
have?
thought
yeah.
I thought
that makes sense.
343 was the the 371. It's 27, 343, and 1, correct? That's what the what needs
Yeah.
to be added together.
Yep. So it's not adding those. That's why only these are working, because they're single digits. So something's wrong with adding those three.
This number.
Okay. What am I doing? It's not.
So I think
Oh,
it's resetting your number when it exits your loop and it goes back into the for loop.
it's doing the first one. Yeah. And then some isn't being. I think I might just have to put it here. I don't know.
Well, you're putting the sum conditional if the sum already is that number, so it shouldn't qualify, right?
Oh, yeah.
I'm wondering if your sum plus equals int digit to the power is somehow not summing
It's
it.
not, so yeah, it's doing it for that single digit. It's not going through each digit of the number.
Oh, I think it's because of when we are resetting the sum to 0. So that's why we're not seeing all those sums add up for each digit.
Well, why don't you sum 0 at the top, like, so it'll go through the loop, do whatever, go back to the top, you can re-zero it, then you know all of your actions are taken.
Yeah.
Yeah, so yeah, about there, around there. I would say maybe between 14 and 15 before it's iterating through the digits.
It always does this. And then still do
Could it be the else, the 0 and the else? Because it's not ready to append that number yet because the sum doesn't equal the number, so it's still resetting. All right, let's try that. Nice.
so I don't even need this else now.
Yeah,
So then if I try this bad boy. Look at that.
Our
We did
powers
it.
combine, Captain Planet.
Ah, I love it. So now going back, so the main issue was basically just sum wasn't resetting.
Mhm.
I think that's the only line that changed, right?
Pretty much.
Digit and string. Yeah, wow. Maybe I should get rid of this one and move it down here after too, but just so it's awesome. Thank you guys. I feel so much better.
Right on. Great work, everyone. All right, let's see.
How do I get out?
With that, I think we could call it a day.